So welcome back to everyone, and today we are going to see about seaborn library. Okay, so seaborn is giving extra features to matplotlib. Okay, so it's quite advanced from your matplotlib library. Okay, so and the seaborn, first we have to install it using pip install seaborn. Then after that, we have some plots. Okay, distribution plots and categorical plots, matrix plots, grids, regression plots. Okay, so we have those plots types in seaborn. Okay, so seaborn is quite advanced from your matplotlib. Okay, so today we are going to see distribution plots in seaborn library. Okay, first you need to install seaborn library from your pip install a seaborn command. Okay. Okay, so I'll share the screen. We'll see what is distribution and how to do the tasks in seaborn library. Okay, first you have to install using pip install seaborn. Okay, so the spelling is seaborn. That's all. Okay, so in today we are going to see what is the distribution plots. Okay, so in distribution we have five types. One is deistic plot, that is distribution plot, and another one is joint plot, then pair plot, then rut plot, the final one is KDE plot. Okay, so we have five types, and first you need to import like this. Then after that, you have to mention if you are using. Okay, first you need to import cbound. Okay, then give what alias name you want. Okay, see here I have give SNS alias name for cbound. Okay, then after that you have to give percentage matplotlib inline. Okay, so this command will work only in your Jupyter notebook. Okay, so the command is using to show your plots in Jupyter notebook. Okay, so if you are not giving this command, we have to mention sns dot show. Okay, same as your matplotlib library. Okay, then here seaborn has some sample data set. Okay, so we can use that data set to develop, or we can do practical things. Okay, so we can do practice for that data set. Okay, so for importing your data set in seaborn library, you have to give one variable name, then after that that alias name which we have given in here, then after that load data set. That's all. Okay, then after that load data set and tips. Okay, so tips is a sample data set. Okay, so this data set is using to you can do practice for sample data. Okay, it's just sample data. Okay, so here I have loaded the data set, then I have stored the data set into tips, then Then so head command we have already seen that, right? So if you are giving any value in head, it prints that value from your top. If you are giving 3, it prints top 3 rows. If you are giving 5, it prints top 5 rows, right? And here if in you didn't give any value in here, okay, so it just print what are the data in your data set. Okay, so it's loading. We'll wait. Okay, it's loaded. Okay, so if you're giving head, it returns all the data which we have in our data set. Okay, so you can see. So here we have total bill, that is total bill amount, and tip. So tips for the bearer and who is ate the food. Okay, who had a food. Female, male, 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 and female. Okay. So and then smoker. Those are not a smoker. And they are eating the dinner in Sunday, and the time, that's a dinner time, size 2. So the female has eaten 2 meals and the male has eaten 3 meal and 3, 2 and 4. Okay, these are the data set which we have. Okay, it's like your hotel data, right? In Sunday dinner time. Okay, so first we're gonna see distribution plot. What is a distribution plot? Okay, in distribution plots we have, you have to mention only one data. Okay, so only one data. If you are giving total bill and it gives the distribution factor. So the distribution means it gives the linear line for your total bill. Okay, so here instead of matplotlib we are using seaborn. Okay, seaborn is a library. It has more visualization effects compared to your matplotlib. Okay, it's quite advanced. Here we have called sns.deskplot. Okay, and after that we have passed the data which we have stored in here. Okay, first we have to, you have to load the data. Okay, first you have to load the data and you have to save the data into one variable. Okay, after that you can use that variable to plot the plots. Okay, here just we have given sns.dast plot tips, and the same process we have used in our matplotlib. Okay, if you want to plot a single column, you have to call like this. Okay, then it gives the plot like this. Okay, so here you can see we get two plots. One is histogram and another one is kde. Okay, so if you are giving dist, it gives two plots. One is the sine wave line is, okay, the dark blue color line. You can see here the line is KDE, and here you can see the bars. The bars are histograms. Okay, if you don't want to see the line KDE, simple, you can give comma here and type KDE equal to false. KDE means kernel distribution. Okay, so if you want to lose this, you have to give KDE equal to false. If you are giving KDE equal to false, the sign line, okay, the wave has removed and you can only see the histogram. Okay, you can also increase the bins. Okay, the each bar is called bins. Okay, the each bar is called bins. You can improve the bins, the number of bins. Okay, by giving like this. First you call your value from tips and total bill is your column. After that, you don't want to print KDE wave. That's why you are giving KDE equal to false. Okay. Then after that, you can increase the bins. Okay. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So almost 10 to 12, right? So we have 10 to 12. Here I give 30. So look like, okay. So see, the above is minimum number of bars or bins, and here we get more number of bins with the same data. Okay, so uh, it's more clear. You can view the entire distributions. Okay, so you can see in each value they prints 2 bins. Okay, so you can see clearly. If you want to print 100 bins, you can give here. Okay, because in here we have only 1, 2, 3, 4, 5 values. Okay, the 5 is a note. Okay, if you want to print more than 5, it takes two bins. Okay, like this. Okay, and this is called a histogram. Okay, is this clear?
Yes, sir.
The next we are going to see join plot. Okay, so the join plot means if you want to get total bill and the tip count. Okay, so how many amount the payer will gives to your hotel, because if you are adding tip and total bill, you can get the amount, right? So the join plus is used to get the difference or get the total value from your two numerical columns. Okay, so here I'm gonna add total bill and tip. Okay, in join plot. Okay, so the join plot allows you to basically match up to disk plots. Okay, match up two disk plots for bivariate data with your choice of what kind of parameter to compare with. Okay, here we can use scatter, reg, resid. Okay, then kde and hexa. Hexa means you can get hexagonal values. Okay, so kde means you can get kde, that is curve, right? You can see the sine wave, right? So scatter means scatter is dotted values. Okay, so if you are giving joint plot, okay, so first you need to pass the value. Okay, x value and y value from your tip. Okay, so first you have to pass the x value, that is total bill, and the y value is tip. Okay, and you have to pass the data equal to tips. We are calling the values from tips data set. Okay, in tips we have total bill and tip. Okay, and then kind is for you can get the plot like this. Okay, this is the above one is x1 and the right side one is y. Here we have given total bill in x, that's why we are getting higher bars here. Okay, so here we have given y equal to tip, that's why here we get some lower bars. Okay, so after that, we are giving scatter for comparison plot. Okay, so kind is for comparison, that's a matchup plot. Okay, you can measure the dots. Okay, so it based on your tip and total bill. Okay, in you take this dot. Okay, in tip we get some 1.8 something, and here in total bill you get some 20 to 30 around, right? If you want to change the scatter plot into kde, you can give like this. So or this is hexagonal. Okay, so you can give hexagonal if you want to change that scatter plot into hexagonal plot. Okay, your hexagonal plot will look like this. Okay, they point out the values in hexagonal shape, and if the value is high, the based on the growth, it will darken the color. Okay, in here you can see there are black colors, those are more higher than other values. Okay, so here it's quite lighter, okay, compared to this quite darker, right? And this is lighter, okay, and this is low value and this is high value and this is more high compared to those, and this is finally the maximum value. Okay, so in the hexagonal graph, if the value is high, it gives darker color. If the value is low, it gives lighter color. Okay, so based on color, based on value, the color transparency will look like this. Okay, this is your hexagonal, and if you want to give KDE, you can give KDE here. Okay, so this is REG. REG means the plot will look like this, and it gives a linear line between your scatter plot. Okay, so in this concept will work in machine learning program. Okay, so if you are giving reg, the plot will look like this. Okay, so the plot gives data for maximum possibilities between tip and total. Okay, then next, if you are giving KDE here, I'm going to change REG equal to KDE. Wait, it's loading, and your plot is look like this. Okay, so KDE means it's a line, it's a curve. Okay, so even it's going darker, and the darker place is maximum value and the lighter place is minimum value. Okay, you can plot any visualization using seaborn. Okay, so seaborn is quite advanced compared to your matplotlib. I'm going to change KDE to REG. Okay, the same existing one. And next, we're going to see pair plot. What is the difference between join and plot? A pair. Okay, join is combine two columns. Okay, so to print like this. Okay, and the pair plot is used to if you're giving tips. Okay, so here you specify one column or two column. If you're giving join plot, you have to give two column. If you're giving dist plot, you giving only one column. Okay, so the pair plot is using to print what are the numerical values in your sets. It takes all values. Okay, here we have total bill and tip and also the size. Those are numerical values, right? We have three numerical value columns. Okay, this take the pair plot concept takes those numerical columns. Okay, then it plot like this. Okay, you can pass only the name. Okay, tips, that's the variable we have stored the data set, right? So it takes, you can see here, total bill and tip and the size. Okay, and also here we have a total bill, tip and size. Okay, and it takes the three value and gives three possible outcomes. Okay, so first it takes total bill, and the first value is which is total bill, and y is total bill and x is total bill. Okay, and the second one, y is total bill and x1 is tip. Okay, so this column or this plot between total bill and tip, and third one is between total bill and size. Okay, the same as here, and the plot is between tip and total, and this one is between tip and tip, and this one is between tip and size. Okay, the final one, and this between size and total bill, and this one is between size and tip, and this one is between size and size. Okay, so your pair plot will gives the plot like this. Okay, it gives possible combinations or what are the numerical values in your data set. It takes all the value and gives possible combinations. Okay, is it clear?
Yes, sir.
Okay, so next one is if we have two categories in sex, right? So we have female and male. If you want to print what are the customers, what are the customers are male or what are the customers are female, and what is the total bill? Okay, so you can give hue value. Okay, so here I'll show, and in pair plot you can use hue keyword and you can pass the column, that is 6, right? So here in 6 we have a female and male. Okay, then after that it gives the plot like this. You can see the variation between this and this, right? So I'm gonna remove the palette. I'm gonna run this. You can get two different color values. Okay, so you can see, and the orange one is for male and blue one is for female. Okay, orange one is for male and the blue one is for female. Okay, so the orange one is for male and the blue one is for female. Okay, if you are giving palette, so the palette is used to giving cool colors in your plot. Okay, so I'm gonna paste that palette. Okay, so before that I'm gonna give KD. I'm gonna run this. Okay, so the palette gives the cool and warm combination. Okay, cool is for blue and warm is for orange. Okay, it gives the value like this. Okay, so you can easily measure, so how many male candidates and how many male customers and how many female customers by using pair plot. Okay, so pair plot and hue function. Okay, then so next we are going to see rug plot. What is a rug plot? Rug plot means it gives like your barcode. Okay, so if you are giving calling total bill, okay, in total bill we have some values, right? Okay, it gives the value indications like your bar chart. Okay, so rug plots are actually a very simple concept. They just draw a dash mark for every point on a univariable distribution. Okay, they are the univariable means single variable. That's all. They are building block of KDE plot. What is KDE? And this one is KDE, right? Okay, these plots are KDE plots, kernel distribution plots. Okay, and the rug plot is act as a base of your KDE plot. Okay, so this is your rug plot. Okay, so it gives like bar charts. Okay, and it indicates only the value. Okay, so here we have called only one column, right? So in first one the total bill and total bill values like this. Okay, so it indicates that value as single values. Okay, so now we're going to see KDE plot. Okay, the rug plot act as a base for KDE plot. Okay, so KDE plots means kernel density estimation plots. Okay, what is kernel density estimation plots? Replace every single observation with the Gaussian distribution, that is normal distribution. Okay, so we are calling the KDE plot as a normal distribution. Okay, so let's see, we have some codes here. Okay, I'll explain from first, okay, here I have using numpy as num. Okay, I have imported a numpy plot, say numpy library. After that I have imported matlab, and after that from sciping. Okay, so don't worry, we'll see the entire coding explanation. Okay, so first I'll show what is kde and what is rug block. Okay, so the rug block, you can see the blue lines, those are rug blocks. Okay, so the rug blocks act as a basis of your kde. Okay, in here the each rug block, okay, so in here each rug block represents the maximum point of your kde. You can see this plot indicates the maximum value of this kde, and here you can see this plot indicates the maximum value of this one, and this one indicates the maximum value of this one. Okay, so we can easily measure them. Okay, so if you are giving a rug block and kde block with the same figure, you can easily measure both values. Okay, then finally, so we're gonna draw KDE plot, KDE single plot. Okay, so just I'm gonna give some value here. Then after that, I'm gonna plot X value and Y value. Okay, then color is Indian red. Okay, so we have so much of color options. Okay, then after that, I'm gonna give SNS equal drug plot, and I'm gonna call a data set. Then the color is Indian red. Okay, the after that, I'm going to use white ticks. Okay, the white ticks for removing the y value. Okay, so that's all. And here we are giving white ticks means we can give the value, and here I have passed the empty value here. Okay, and the subtitle is some of basic functions. That's all. Okay, so here the subtitle has placed it. Then after that, this is KDE for your data, and you can see the each rug block represents the value of your each KDE plot. That's all. Okay, you can know, or you can find the rug block values, KDE values, by using rug block value. Okay, so here I have given KDE plot for tips to find the tip data set. I have called total bill, and also I have given a rug plot for total bill. Okay, you can see the values. Okay, I have drawn KDE plot for my total bill rug plot. Okay, so it's simple. Okay, so you can measure from these, and when the KDE cross the line, you can hold it that place, and you can measure what the value here. Simple. And you can measure the total bill in here, and the total bill is some 8 or 9. Okay, here 8.5, 8.2. Okay, so if you, I'm gonna use tip column. Okay, here I have used the total bill, and here I have used the tip. You can see the variations. Okay, here you get the clean curve because this is total bill. Okay, here we have some fluctuation due to the data. Okay, we can get some fluctuation. Okay, so, and the each rug plot, that is each line represents the value for here. That's all. Okay, so here we have like 1.5 to 2.5, and this is 2 and 4. Okay, so the reason for using both plots in single figure, we can easily measure the values. Okay, here we are using only total bill, right? Here we are using only total bill. You can easily measure what is the bill amount. Okay, so what is the bill amount by using the rug plot. Okay, and you can see the growth for using KDE. Okay, this is the difference between rug and KDE. So always the rug plot will use as a base for KDE. That's all. Okay, is it clear?
Yes, sir.
Okay, so thank you all. Do practice. Okay, so this concept will give some
Sir,
confusions. Yeah, tell me.
what
Yes,
is RGSID, sir, in joint plot?
in joint plot, right? REG, right?
RGSID.
So RGS ID gives your plot like this. If you are giving RGE, REG, and it will both the same.
RESID, sir.
RES ID, right? It gives the linear line. I don't know the exact meaning, but your plot is changing like this. Okay, so if you are giving REG and it looks like this, and if you are giving RESID, your plot changed into two. That's all. Okay.
Okay, sir.
Okay, so these are about the distribution plots. Okay, and we'll see the categorical plots and matrix plot topics we'll see on tomorrow. Okay, so tomorrow we have a webinar on our resume submitting and resume editing in 3:30. Okay, so I'll inform the class time. Okay, so because the webinar takes more than half an hour. Okay, so I'll explain. I will inform the class timing within the evening. Okay,
Okay, sir.
yeah, thank you all.
Okay, sir.
Thank you, sir.
Thank you.